Hello everyone, and welcome to the Vmware VCP7 course. This course is being taught by my boss and very talented IT instructor Syed Amir Shahzad. You will get to learn it with clear concepts-based lectures, colourful diagrams, fun and jokes, and best of all, step by step, hands-on, labs. Let's tune in to Amir's Vmware course.
Last time we were talking about these things: VApp, resource pools, VM management. Now we need to go for more importante topics like standard switch, vMotion, distributed switch, cluster, and then lots of more advanced features in cluster. So we're going to start with the standard switch. And for that, first of all, I need to still connect to our resources. So I'm gonna go for Samuel machine. Samuel, thank you for volunteering. 41 minutes lease. Okay. Renew lease. And 40 minutes lease left. So renew lease and renew and and new. Okay. I'm gonna now connect to the VM. Oh, okay. Samuel, you have to close the screen on your side.
Yeah, I just closed it, sir.
All right. Thank you for this. And okay, so we're connected now. So in last episode, class, what we were doing was this. So VApp, just a grouping of virtual machines to start, stop, or restart them together for maintenance purpose. Resource pool was, hey, anyone can give me a one-liner for that? What was resource pool? Quick. I got you all. Nobody know what is resource pool.
Can I try? Hello?
Yeah.
Can you hear me?
Yes.
Yeah, resource pools can be able to say it's like a folder where you are able to create the different centers, like the way you did the Toronto and the US. That can be able to share resources.
Well, so just one word for this before when you go to the interview, just remember that it's all about reservation of CPU and memory, right? So always keep that in mind. Always keep these words: grouping of VMs for maintenance. This is VApp, right? And virtual machine management is, yeah, you manage the virtual machine. I mean, that's this thing. Standard switch, let's get started with that. So standard switch are, switches, virtual switches that provide networking to the virtual machine. So a standard switch gets installed when we install the hypervisor for the first time, right? So that's first thing. Standard switch, so we call it we can also call it, right? So we can also call it virtual standard switch, right? So VSS, virtual standard switch. Okay, virtual standard switch. and VSS gets connected to the physical NIC, which is network interface card, network card, right? Of the hypervisor of the physical server, right? And VSS has many components, and it has port group, which offers connectivity to VMs, so they could share data with each other and to the outside world. Okay, so VM, it also has virtual standard switch. Okay, instead of it, I should just clarify that too. VSS has port group, and we're going to be creating all that. We're going to be understanding inside out of a port group. VSS also has VM kernel port, VM kernel, kernel. Okay, VM kernel port. I've seen too many movies. So yeah, VSS also has VM kernel port, and which offers networking to advanced features of VMware for like vMotion, and vSAN, and FT, etc. Fault tolerance, right? So it has lots of features that we need to explore. But basically, that's what the virtual standard switch stands for, and that's not standard switch. That is virtual standard switch, right? So first, I'll just copy paste that here. Okay, now if I go to the diagram here, and I'll grab the diagram that I've been creating that would be the better one. So this one. Okay, so these are our 4 machines, right? 4 virtual machines that we created. So the virtual standard switch would be okay. Oh, where's the pen? Yeah. Okay. So I'll just make it bigger. Now, these are the, right? So suppose these are the virtual standard switches, right? So VSS. So when we create a virtual machine, that virtual machine also has, and I explained that before as well, I remember. But this would be a good repetition because now we're talking about it. There is a virtual machine. That virtual machine has a virtual network card, right? That virtual network card needs to have networking, right? So it needs to connect to the network. So virtual standard switch is already there because when you install the hypervisor, the virtual standard switch got created automatically, right? Now, virtual standard switch has components, and those components are so first of all, this is the port group, PG, right? So port group is part of virtual standard switch. Virtual machine, through its virtual network card, will connect to the port group, right? And that's another rule of thumb. A virtual machine can see a port group, see and connect to a port group, but cannot see a VSS, virtual standard switch, or the physical NIC. Oh, what does that mean? So if you go back to the diagram here, virtual standard, virtual machines, virtual network card, through that virtual machine can see this guy, PG, but cannot see this guy here, the virtual standard switch. When we say see, it means C senior, yeah, but I don't mean that C, but I mean by that the C is looking C. What am I talking about? Yeah, okay. Anyway, so here virtual machine will never be able to connect to directly to the standard switch, or will not be able to see it, but it will only see port group, and I'm going to show that now. And second thing is virtual standard switch is connected directly to the physical network card of the physical server inside which the hypervisor is installed, right? So virtual machine will only be able to see port groups. So you can create multiple port groups here. Port groups are used for organization purpose as well. For example, if we create PG1 port group 1, this is not parental guide for kids. When you go to Netflix, this is PG1 port group, and that is port group 1, suppose, is for sales department. So you can create another port group which is for marketing department, right? And then you can create another port group which is for administration department, suppose. So why would you need the separation, separate port groups? So suppose you have like 10 virtual machines here, and these different virtual machines belong to different departments, right? So suppose this virtual machine, I have to create samosa like thing here as well. Okay, and so suppose this is this virtual machine belongs to administration department. This virtual machine belongs to, suppose, marketing department. This virtual machine, these two virtual machine belongs to sales department, suppose. So you can use the port groups for organizational purpose as well. Well, port groups even have more deeper features than this, but the thing is that port groups are there to let the virtual machine connect to the network, to share data with each other and to the outside world or the internet. You can create 128 total port groups, and these port groups offer VLAN features as well. We're going to be now diving into that as well when we do practicals lab. But what we need to understand here now is port groups can be created for organization purpose. If these three port groups are connected to the same standard switch, then obviously, if the VLAN is not created, so each port group, you can configure VLAN as well, right? So VLAN here, VLAN here. If it's 0, obviously they can, virtual machines connected to this port group and virtual machines connected to this port group, they can communicate with each other. But suppose you have a VLAN 1, you have created VLAN 2 here, and you've created VLAN 3 here, and suppose you have created VLAN 4 here on each port group. This port group has VLAN 4, this port group has VLAN 3, this port group has VLAN 2, suppose. So because the VLANs are different, so the virtual machine, these virtual machines connected to VLAN 2 cannot communicate with this virtual machine connected to VLAN 3, or to this virtual machine connected with VLAN 4. If they're all VLAN 0, 0, 0, or same number, whatever same number, 2, 2, 2, 3, 3, 3, whatever, right? So they can communicate with each other, or if the numbers are different, they cannot communicate with each other. This is used for segmenting. Suppose you do not want marketing department machines to be able to share data or run a ping just to check each other's machine if they are over the network. So basically, if these machines do not want to share data with this machine, so you can create another port group, put a different VLAN there, and once it is different, these machines won't be able to communicate with this machine, although they're all connected to the same standard switch. So yeah, VLAN feature is supported on port group level. We can create even more standard switches. We can create here standard switch 2, standard switch 3, standard switch 4, right? We can create standard switches here as well to regulate the traffic because the standard switches, extra standard switches, what is the benefit of creating extra virtual standard switches? So suppose you have here 8 network cards or 10 network cards or 6 or 4 network cards, right? So you can do a pairing of that, which we also call as NIC teaming. So suppose this first virtual standard switch, normally VMware gives it a number itself. So VSS0, the first standard switch starts with 0. VSS0 is connected to this network card, right? Physical network card. So second switch, you can connect to this physical network card, suppose. And third switch, you can, virtual standard switch, you can connect to these two network cards. They can just form NIC teaming, right? They can just form NIC teaming with each other. And then it's a pair. And they are both providing the traffic to this network card. And they all have this virtual standard switch. And each virtual standard switch has minimum 1 port group, but you can create multiple port groups in multiple standard switches as well. So if this machine connects to this standard switch, suppose, and this standard switch is connected to this network card, so obviously this is totally different traffic. Like suppose it has huge traffic. Suppose it has, it's a file server, suppose, right? And there are thousands, there's maybe 2,000, 2K users are connected here, right? So that's a lot of data that is going in and out, inbound, outbound traffic is huge, right? So in that case, this traffic is from this machine is going to this standard switch, and this standard switch is connected to separate two physical network adapters, which means that this network adapter will not be overwhelmed because it has its own machine traffic to handle. So this machine's traffic is totally moving on a separate uh, network card, standard switch, and separate set of network cards. And this machine's traffic is moving on a separate standard switch and a separate physical network card. So you can make the whole traffic within the same hypervisor. Two virtual machines can traffic from two virtual machines can be totally separate from each other without touching the same standard switch, without touching the same physical network card. They can be made to go for the traffic flow could be on a totally separate um, you know network path, right? So we can create all that. So we can create multiple virtual standard switches on a hypervisor. We can create on each virtual standard switch multiple port groups as well, and we can regulate the traffic. And each port group supports VLAN. So even on a port group level, on a same standard switch, two port groups, we can just disconnect the traffic between the two port groups, or we can connect it back between the two port groups on the same standard switch, right? So this is how virtual standard switch you can create more. You can create port groups there. You can regulate the traffic. You can disconnect the traffic or separate the traffic totally without overwhelming. So all this we can see now in this episode. Okay, in this class, yeah. So let's go and check it out. Check what out? So we're going to go for our lab environment. And there, what we see is that there are VApp. Last class, we created the VApp. We created a sales. We created a resource pool there, right? And we created also we created also the what? The image, right? This thing. This is not a virtual machine. Anyone knows what is this? This icon is not virtual machine icon. Virtual machine icons are this. What is that? What is this icon representing? Anyone knows? Because it's not a virtual machine. Then what it is? What is it?
The template?
Template, exactly. Okay, so this is a template with where you can create an image, right? Okay, so we don't need the VApp, we don't need the sales resource pool, we don't need the resource pool, we don't need the VApp. So first I need to take out the virtual machines from the VApp. I'm gonna move these virtual machines to the root of the hypervisor here, so I could delete the VApp later. So first of all, I need to move out the virtual machine. So I'm just gonna drag this virtual machine and put it on top of the hypervisor ESXi02. Okay. So I put it there. I'm just gonna move the other one, and put it back here. Okay. So here, now we have an empty VApp and an empty resource pool. Okay, so we will be deleting those two guys because we got we understood that, we did the lab for that. So I'm just going to right click here, and where is the delete button? Delete button is here. Delete from the disk. So okay, so I'm going to delete from disk here, and whereas yes, then I'm going to delete the resource pool as well. We don't need that. Okay, so once we delete this resource pool, we got the virtual machines here, the two virtual machines, in fact, three. One is here as well. Also, you can see that, oh, that's not a virtual machine, that's a hypervisor. Okay, so two virtual machines total. I think I created more last time. Anyway, so, oh yeah, then I can just convert this template into a virtual machine as and well, right? So if I right click here, where is that? Oh, it is a virtual machine. Oh man, seriously, it was a virtual machine all this time. It was not a template, man. If I go to here, okay, so we converted the virtual machine, the template last time we converted back into the virtual machine. Okay, my bad. Yeah, this is a virtual machine, not a template, because you can right click and see the power button here, right? So templates don't have power button. I'm gonna just shut down those machines because we have very less RAM in each hypervisor, so I don't want to consume that RAM. So I'm just gonna right click and power off these virtual machines. UI. I'll press UI. UI means yes. And right click here, power off. And yes. Now, while these machines are powering off and we get to save our, say what? So we get to save some resources here. I'm going to go to the hypervisor level for ESXi2. On the hypervisor level, and they're still green, right? Green means playing or started. So I'm just going to refresh that. Okay, they're still working on it. So yeah, on the hypervisor level, I'm going to click that, and then I'm going to go to configure this one. Why? Because all the configuration for the hypervisor would be here. And I would want to go for networking section here, right? So hypervisor configure networking. Under the networking, we see virtual switches, VM kernel adapters, physical adapters, TCP/IP configuration. So I'm going to go for virtual switches. And you can see that it shows a cool diagram here as well. And that diagram really explains the whole thing. So you can see here, first of all, if I just collapse this, right? So it's V switch 0 or VS0. Virtual standard switch is also it is on, but V switch 0, we can also say that. So I'm going to expand that again. Now, if you see this diagram, so this is the switch. The right side is the physical adapter. VMNIC 0 is the physical adapter. And so this is the physical side of the switch. And this is the virtual side of the switch. So there is a management network and there is a VM network. So what are these? So as I was saying before in the diagram as well, that there is a port group. And VM kernel adapter, obviously, we will be doing a lab on that as well. But VM kernel adapter is also part of the virtual standard switch, and its purpose is to offer networking to advanced features like vMotion, fault tolerance, and vSAN, etc. Right? But we see a port group here. One port group always gets created on a standard switch. So if I go back here, so this is that port group. The default name of the port group is always VM network, right? That's a port group name. We can rename it always to anything. We're going to be creating more port groups, and you will see that too. But there's a port group here, and you can see that there's number 3 written here. So 3 virtual machines are connected. We have total 3 virtual machines here. Hey, did I not stop this? If I right the clicker here, why is the green play button showing here? Okay, so they are stopped, but the dashboard was not updated, and the green play button is not gone, still showing. So if I refresh that, and green play button don't want to go. All right, no problem. You're welcome here. Green play button. All right, anyway, so here, a hypervisor, configure, virtual switches, and then, so this is the default port group where the virtual machine, 3 virtual machines are connected to. So if I expand that, you can see those virtual machines here that they are connected to this port group. And this port group is connected to the virtual standard switch 0. This is the name, vSwitch 0. This is vSwitch 0. And this vSwitch 0 is connected to the physical adapter. Remember in the diagram, so suppose this is a port group, this is virtual standard switch, and it's connected to a physical network adapter, right? So that's what it's showing here in the diagram as well. O and K. Now, there's that VM kernel port also available. Again, I have already mentioned that VM kernel port is responsible for offering networking to advanced features. Now, one of the advanced feature is already here. So this VM kernel port is called management network. Management network. Oh, what is this? Well, this is, if I go to the diagram here, when the new hypervisor is deployed on a physical server, so a standard switch gets created. Yeah, we know that. So, and when a standard switch gets created, so there is port group that gets created, and there's VM kernel port. VM kernel port offers networking to advanced features. Okay, so where's the advanced feature here? Well, this guy here, management network, this is advanced feature. Okay, what's the advanced feature? What is it doing? Management network is responsible for letting us remotely connect and manage the hypervisor. right? So basically, if we basically yeah, here. If this VM kernel port called management network was not there, then we won't be able to remotely connect to the ESXi02 from our vCenter, right? So thanks to the VM kernel port called management network, we are able to remotely connect from the vCenter or from the browser to the hypervisor. So this is because of this VM kernel board. So obviously we need to remotely connect to basically configure it and use it. So that's why it's very important that this port be created when the hypervisor is first deployed, right? So if we want to remotely connect through the vCenter or through the browser, through the vCenter if you want to remotely manage a hypervisor, or through the browser if you want to remotely manage a hypervisor, you need a VM kernel port called management network. So if it is closed, it's not there, we cannot remotely connect it. So obviously it's very important, right? So these two you will find in the standard switch in every hypervisor, and these are necessary. So now we get that, okay, so there's a port group here called VM network, and port group offers networking to virtual machines, because you can see automatically virtual machines are connected to this port group. We never connected manually this, right? Now, if we go to the physical adapter side first, we can make it redundant as well, which means instead of one physical adapter, we can have two physical adapter, or three or four or five, right? Remember that we added 9 more network cards, making it total 10 network cards. So this was the reason I wanted to show you how to add 2 different features, more network adapters, right? So currently one physical adapter is active with this standard switch. Okay, then where are the 9 other? Why are they not being shown here? Well, we added, if you go to the diagram, so this is XI2, I'm connected, right? So 9 more NICs are still there, but we only see one network interface card there, right? So we have to manually add and activate the rest of the network cards or any other network card manually. It's a manual process to attach, to tell the network card which is already there, to tell it, hey, now you're going to be teaming up with this first physical network card, and you will be connecting to the standard switch 0. So we have to do that manually. So first of all, let's try to check how to add a physical network card, or how to assign a physical network card to a standard switch, right? How to assign a physical network card. So do we need it? Suppose these 3 virtual machines create a huge amount of traffic. Lots of traffic. Suppose it's a file server here, this VM01, it's a database server here, suppose, and this is a web server here, and so many users are connecting to this. So one network card is being overwhelmed with all the inbound, which means traffic coming from outside to inside, or outbound, which means traffic coming from inside to outside, right? So there's so much, suppose there's so much traffic going on, and your boss says, hey, can you add another physical adapter, assign another physical adapter to this standard switch? And you say, yeah, sure, why not? So as soon as you assign, they will team up together, right? And the traffic will automatically be distributed to both the network cards, right? I think I mentioned one more thing here, and that was LCB, no, LBFO. Yeah. So here, and anyone remembers that? I'm sure one of you remembers it. Where was it? LBFO was what?
Load balancing failover.
Yeah.
Load balancing and failover. Yes. Okay. I'll throw another term here. So this, if there's a single network adapter here, so it is offering right now SPF. Anyone knows what does that mean? This is SPF and this is not good. SPF should not be there because it's just one network card here and it could be SPF. Anyone knows the abbreviation of that? What is SPF?
Single point of failure.
Yes, exactly. Great. So single point of failure. If there is one network card here, and because it is overwhelmed with huge amount of traffic, suppose, and that only one network card is not available, so all the traffic is stopped abruptly and there is a downtime and then you're in trouble. So we should never have single point of failure on any level of network. Single point of failure. Okay. Failure. So what does that mean? A single point of failure, as I said, that there should not be one of any important component, right? There should be, maybe you can create two virtual network cards even in the virtual machines here. If the virtual machine is very critical, make a partner virtual machine here, which is the FT feature that offers the partnership. So this is the active machine and this is the standby machine, right? Which is creating a copy of per second copy of whatever's happening in the active machine. Then there are two network cards here. Then there could be two standard switches here, and one network card connected to one standard switch, second network connected to a second standard switch. There could be two network adapters. This standard switch is also connected to two network adapters, suppose, and this is also connected to two separate network adapters, or four or three, right? So there should not be any single point of failure. And outside suppose a network card is going, so it should be having two physical switches, right? And two physical switches are there. Each switch should have two power outputs, or at least whatever physical rack the physical switches are in, those physical racks should have two power outlets, right? So there should not be any SPF on any level. So this physical switch goes to the router. There should be two routers. The firewall, redundant firewall should be there. Storage, there should be redundant storage there. So the point is there should be no SPF. Avoid having SPF anywhere. So that's another thing, right? Now that's what I'm saying right now. Let's add another network card or assign another network card to our virtual standard switch. So I'm going to go back here. So there's one physical adapter. How do we add a second physical adapter to this virtual standard switch 0, V switch 0, right? So it mentions there as well, manage physical adapters. We can go here, or add networking. We can go here. From both places, we can add a second, third, fourth, fifth physical adapter. So I'm going to go to manage physical adapters here. And one day, Monday or Sunday, it's going to open. Really? So if you do that, sometimes it goes faster. If you make a square like this, right? Sometimes it's what am I talking about? Seriously, what's going on with this? Hello, knock, knock, knock. Anyone here? Oof. Oh, okay. I'll refresh that because, well, it's not responding. I think it will kick us out, maybe, or not, or kick us in. All right, now it is back. So I'm going to go back to manage physical adapters. Okay, so we click the manage a physical adapter, then we see that sign here and we get hypnotized. What? Again? Really? Hello? Don't stare at it. You know, you may get hypnotized and then, you know. Oh, Nuruddin says he's okay. His is okay. Come on, man. Okay, there's another way. I'll try another way. That's weird. Okay, guys, there's one way to add physical. Okay, even there's an activity going on here. So there's one way to come here and add a physical adapter. There's another way, add networking, right? But yeah, there's something going on here actually. Oh, now it's okay. It or not. It's still doing this. So I'm just gonna. Okay, one more try. Really, dude. Knock, knock, knock. You're gonna keep on loading. Okay. So unable to log on to my V Center. Mariam says, oops. Uh, okay, so yeah. If I just try this one, add networking. Oh, it's okay. So that's another. Okay, Mariam, let me just go through this and then we can t-shoot the machine. Okay. I tried here and it didn't go ahead, but the same thing we can do here as well. Add networking to add another physical adapter. So I'm just going to go through this way, add networking, right? So if I click that and it shows this, so there is physical network adapter showing the as a third option. There's VM kernel adapter if you want to add a VM kernel adapter. That is when you're trying to add any of the advanced features. We're going to be coming to that. There's a second option here, virtual machine port group for a standard switch. Now this is if you want to create a new port group, or if you want to create a new standard switch, then you come here. We're going to be coming here, obviously. But right now, we need to add another physical network card from the 9 or total 10 we have. So I select the third one, and then I'm going to click next. And it says which standard switch you want to connect this new network card to. Obviously, that's the only switch we have, and that's where I want to connect another network card, right? So yes, that's a existing switch, and then I'll click next as well. Uh-oh. Something with the E6i2 networking or standard switches, I guess. Oh, one more thing. Hey, did you add 9 network adapters? I'm sure you did, but I will have to check. It's the same screen when we hit adapter. Yeah, it's the same screen. Nordin says in the chat. It is supposed to be the same screen. I thought that from there it might open, but it is not. So E6i2, if I go to this machine and go to details to check the network adapter, number of network adapters, yeah, it has, yep, it has all the adapters added. Okay, so yeah, something is fishy going on here. What I can do is I could just restart this ESXi2 hypervisor, which should not take much time. So this ESXi02, I can go ahead and, well, okay, Miharib also says for me it's work, Shop says it's working. Hey, why it is not working for Samuel? Try ping your machine. Oh, okay. So that's for Mariam, right? How long? Nima says in the chat, how long does it take for E6i1 to turn on? So E6i1 especially the virtual. First you turn on the ESXi1. Suppose you restarted it, then you have to remotely connect. Go inside ESXi1. You have to power on the virtual machine manually. After that, wait 10 to 15 minutes, sometimes 20 minutes, and then you will be able to connect to vCenter. So vCenter is pretty heavy machine, and the amount of hardware we have given is less. So background services take a lot of time. I have powered off this ESXi2. I'm going to power on now. If I had powered off by mistake ESXi1, whoa, then obviously the vCenter shuts down, and then I have to start the vCenter manually with the virtual machine, then wait 15-20 minutes just for the vCenter background services to fully be up, and then it gets started and opens the page. So it's two that I needed to. Okay, it's already loading still. Activating. Yep, it's loading. And it has 8 GB RAM, which is good. Okay, I think it's good now. Starting service VM tool SD, and there's a last point here. This one, last one. But yeah, I think I'll just close the window here and go back to this. Go back to that screen from where we were remotely connected to the ESXi2. Now I need to refresh. So vCenter makes another communication with ESXi02. Okay, so seems like all good. I'll try to add manage physical adapters again. And there it is. Okay, so yeah, now you can see that this screen. I just selected the same screen here, manage physical adapter, right? So I'm just gonna open that. So now assigned adapters. So there's active adapters, there's standby adapters, and there are unused adapters. Three categories here, three areas. So first of all, I'm going to go to the plus sign to assign or add another adapter to this particular standard switch. So I'm just going to click the plus sign, and all the rest of the physical network cards or adapters will be showing here. I will go for the next available VMNIC1 or next available physical network adapter and press O and K. So now there are two active adapters here, right? But also, since there's an option here, suppose if I keep it selected and press the down arrow here. So this will become a standby adapter, which means that whenever VMNIC 0 is not available for some reason, automatically the standby adapter becomes the active adapter if we put it in this way, right? But this also means that standby adapter will not be used, only still one adapter, network adapter will be used. We can create a LBFO configuration here by adding one more adapter, which I will remove later, but temporarily I'm adding here. Suppose I go to plus sign and just the next adapter is selected, and I'm going to press O and K here. Why? I don't need that, and I will be removing that, but just to show the whole configuration, that suppose we want to achieve LBFO load balancing and failover, right? LBFO. So there are two adapters which are doing a load balancing, but the traffic is being divided among the two network adapters, and then still there's a standby adapter. So suppose any one of the adapter goes down, is having issue, not connected, not taking traffic, so the standby adapter can automatically be added as a active adapter, and still load balancing will keep on going, right? Suppose the second adapter that has an issue, it got turned off and then turned on again somehow, then the standby adapter which became active will come back to standby state again, right? So we can achieve the LBFO here. I'm just gonna remove this now. So it is already selected. So I'm just gonna click close or cancel here, the red one, then it goes back to the list, right? Which means it's not being used by this standard switch. So now there is VMNIC 0 and VMNIC 1. There is an unused adapter as well. So if I select it and go for the down arrow here, so this is unused. Unused obviously means it's not even on standby state. This means that if the active adapter somehow is not available, then you have to come here and manually drag it up to the active adapters. Because it's not on standby under the standby adapter, so it won't automatically become the active adapter in case if the active adapter goes down, right? So that's the use case for these three sections here. I still have this selected, so I'm just gonna put it beside the active adapter here, up, right? So that's what we want here right now, because we want the traffic to, although we don't have in our test environment a lot of traffic, but this is how we would have done if it was a production real environment, right? So the two adapters are now there, and we want the virtual machines to use both adapters as they have teamed up together to share the data with each other, right? So I'm going to press OK here after adding that adapter among the active adapters, O and K. And there you go. So the second adapter, VMNIC 0 and VMNIC 1 are both showing now here, right? And this means that we have like load balancing here available, which is, and suppose there were these three virtual machines, if they had huge amount of traffic, so there are two adapters there to really offer the load balancing for a lot of data, and one network adapter will not be overwhelmed. Okay, one more thing here is, if I click that, if I select the whole box here, then you see that the two adapters are automatically selected, which means that they have automatically teamed up together to offer. So these both are being used. These both network adapters are being used for the port group here, right? This port group. But if I click here to the VM kernel adapter, then you see that only one is selected, because this VM kernel adapter, it does not have a lot of traffic. What kind of traffic it is taking? This one, just the remote management traffic, just the remote connectivity, which is like one admin in a big environment, maybe 3 or 4 admins are connecting remotely. So it's not a lot of traffic. So that's why they have automatically assigned for this remote connectivity feature or component just one network adapter. And where the huge traffic is expected from, they have automatically assigned two. So if I click that box here, click this port group here, then both are selected, right? Now, that's one thing that the network adapters, how to add a network adapter, right? Second thing is, what are those port groups here, and can we create more port groups? So we have 3 virtual machines here, right? Suppose we imagine that VM01 and VM02 belong to sales department, and or VM01 belongs to sales department, VM02 belongs to marketing department, suppose, right? And template 01 belongs to administration department. So I will be creating, let's create 2 more port groups, and then we will move VM01 to the sales department port group, and then VM02 to the marketing department port group, just to show that, oh, this is also how to create a port group, and then how to move the machine from one port group to another in order to organize, the machines connectivity. So let's create multiple port groups now. How do I do that? I'm going to go here to up here and add networking, where I went before as well. I'm going to click add networking, and then now I'm going to go for the second option here, which is virtual machine port group for a standard switch, right? This is where we can create separate, another port group or another standard switch. So I have selected virtual machine port group here for a standard switch, and then I'm going to click next. Yes, I want to create next port group in the same standard switch called vSwitch 0. So I'll keep this option selected and click next. Now you can name the port group anything, but there should be some wise naming convention for the port group, right? The port group, and I can explain that in the diagram why. There you can create port groups. One port group is always there with a standard switch. So suppose there are 3 standard switches: one standard switch, second standard switch, third standard switch, right? Or 0, 1, 2. Now there's a port group here. So this standard switch also has its port group PG. This standard switch also has a port group here, PG, right? Now, okay. So here, this port group, virtual machine always only see port groups, right? So if you name those port groups as PG1, suppose this is PG1, this is PG2, this is PG3. Now these 1, 2, 3 belong to standard switch. Then you go for PG4 here and PG5 here, port group here. So but they belong to standard switch 1 and standard switch 2. So we will not know. So virtual machine will only see port group, port group, port group, port group. It will not see standard switches. I'm going to show you now. So the wise thing to do is we should always mention the name of the standard switch that the port group belongs to. So this is vSwitch 0. So I can just name this as VS0, the port group name that is connected to, that is part of the standard switch 0. VS0, PG, and sales. I could just name it like that. And then this is, then there are 2 port groups here, but this port group name would be VS1 PG. Suppose this is marketing, MKT. And then VS2, because this is, standard switch start with 0, right? So virtual standard switch 0, virtual standard switch 1, and VSS2, right? Virtual standard switch 2. So it's wise always to put the virtual standard switch name VS2 PG suppose it's administration department, ADM, right? But when virtual machine tries to connect to another port group, then we will know that, oh yeah, this port group actually belongs to virtual standard switch 1. Oh no, I want to connect to virtual standard switch 0, whatever the reason, right? So naming the port groups is muy importante, right? Very important. All right, so this port group still belongs to okay. So here, network label. So I'm just going to go for VS0 because this port group belongs to virtual standard switch 0. And PG, which is port group, we can name it anything, but we're just trying to be meaningful and wise here. So PG, and then suppose it's MKT, it's a marketing port group, right? Second thing it shows here is the VLAN option, right? So either it's 0 or it's 4095. 0 means if all suppose there are 3 port groups and they all are 0, so the virtual machines connected to the port groups can all connect to each other. But suppose this VLAN is 2, and suppose I'm creating another port group and the VLAN number there I give 3, then virtual machines connected to VLAN 2 cannot communicate with virtual machines connected to VLAN 3. So if you don't want those virtual machines to communicate with each other, then you put a different VLAN. Otherwise, you put the same default VLAN. Or if it is 4095, then it can also that VLAN can communicate with any other VLAN as well. So the VLAN ID is 0, right? I'll keep it like that, and the naming convention I also put there properly. Now I'm going to click next. So this is not a difficult thing. Creating a port group is pretty easy and straightforward. So this is it. Port group is created, and I'm going to click finito, and there you go, finito. So when I click finito here, so now I see that VM network default port group is still there, but now I have another port group to the same standard switch called VS0 PG MKT, but it does not have any virtual machine attached to it because that's a manual process and we will do it later. Right now we're creating just a port group, Okay. So here, once this is created, let's create one more port group. So I'm going to go to add networking again. It's the same process. I'll select the second option and click next. It's the existing standard switch again, so no change here, and click next. And yes, this port group also belongs to the same standard switch. Okay. So then PG dash it's not case sensitive. You can just make it lowercase, uppercase, and then it's suppose it's sales, right? Sales department, and not changing VLAN value as well. So that's it. Next, finito. So now third port group got created, which also do not have any virtual machines yet. Okay. So here, 2 port groups got created, and now I need to move VM01. Suppose it belongs to the marketing department. So VM01, I will detach from the default port group and attach to this one, and VM02, I'll attach to the sales port group. So how to do this? Okay. So VM01, I'm going to go there to VM01. So VM01 is this, right? So I'm going to go to the virtual machine itself. I'm going to right click on the virtual machine because I want to change its network card's connectivity from default port group to another port group. So if I go here to the virtual machine and then right click and go to edit settings, right? Edit settings. And yep, it's the network adapter that we are concerned with for this virtual machine. So if I go to the diagram, this network adapter, this is a virtual machine, this is a network adapter that suppose it was connected to this port group, we are connecting to the second port group here, right? So this, if we just drop down, the default port group name shows here, but we want to browse and check if there are other port groups, Okay, so browse here. If we go there, so there's that these are the port groups, but you can see that there's no show of virtual standard switch name. There's no show of or it's not, or the physical network adapter names are not showing as well. VMNIC 1, VMNIC 0, right? So this is what I was saying, that virtual machines can only see port groups. Virtual machines cannot see standard switch. Virtual machine cannot see physical network interface card, right? So I'm going to select this VS0PG marketing port group for VM01. That's all. You select and press O and K. So yeah, now port group has been changed for the virtual machine VM01, right? So I'm just going to press O and K. And then I'm going to do the same thing with VM02, but to the separate port group. So I'll select this VM02 here. And yeah, pretty much the same thing, right? So right click, edit settings, browse, and then PG sales, press OK, right? The sales port group, right? So its port group has been changed as well, and press OK. So two machines port groups have been changed. So I'm just gonna go to the standard switch to the hypervisor level. Then I'm gonna go to the configure, then go to the networking, then go to the standard switch. I'm gonna check that. How does it look like now? So I'm gonna go to the hypervisor, configure, virtual switches, right? And here, now I see that to the default port group, there were 3 machines before. Now there's 1 machine and 1 machine. So we can just expand that. Yeah, this machine, template machine, we didn't never moved, but we did move the VM01 to the marketing port group and VM02 to the sales port group. So yes, that's how we create port groups and then assign virtual machines, network cards, different port groups, right? Um, so if now that is like how to create extra port groups and change virtual machines. But what about another scenario, which is I suppose there's a huge amount of traffic. So suppose there are virtual machines that have, as we mentioned, FS, this is file server, and 2000 users are connecting to the file server. Suppose that's the case, and it's a lot of traffic. So your boss says, hey, all other machines also have a lot of traffic, and this machine has alone a lot of traffic. So, and all the traffic is going through these 2 network cards, suppose, right? Remember that we added another network card to this standard switch, but the traffic is so much that these 2 network cards also are being overwhelmed. They're slowing down the traffic, right? So what about if we create a second port group? You know what? This is too messed up now. Let me create another diagram and getting that diagram from the other. O and K. So suppose there are lots of virtual machines. So we already have, and they have samosa shaped network cards. Oops. So they have samosa shaped network cards here. Yummy, yummy. And then there are a lot of, so there is, suppose this is a VSS0. virtual standard switch 0, right? And we already have a port group here, right? So we already have a port group. So 3 port groups we already have on VSS0. Now we have, the boss says that your network cards, your virtual machines, yes, they are connected to port group 1, port group 2, port group 3, and this standard switch is connected to 2 network cards already. This is our current situation here. This would be the bigger network card, physical network card, right? So 2 network cards we have assigned to standard switch 0, and 3 virtual machines are connected to the standard switch 0. We're pretending that those virtual machines have heavy traffic, and now if 4th virtual machine is connecting, and we know that it's going to be huge traffic, or it already has traffic, so even the 2 network cards have traffic is slowing down, or even on 2 network cards. So your boss says, hey, why don't you put an extra virtual machine's traffic to a separate standard switch with its own port group, and attach 2 separate network adapters for that second standard switch. So it will look like this. Like this machine, we already suppose this is a new machine that we are creating, and we know that there will be 2,000 users connecting here. So it will be huge traffic. Already all the other machines have, suppose this machine has 3,000 users regularly connecting, 3,000 users. And this machine already has 1,000 users. This machine already has 700 users connecting here, suppose, right? Not 700K users, right? So this, we are already expecting that it's a file server, so 2K users will be connecting here. We are already expecting that. So the boss says that, hey, why don't you just separate the traffic on separate network cards, right? Put the traffic of this virtual machine on separate network cards, and do not put the pressure of all the users for this virtual machine on these 2 network cards as well, because these 2 network cards are already taking traffic from these 3 virtual machines, right? So we decide that what you do is, yes, sir. You say yes to your boss, and then what you do is you create VSS1, right? VSS1, virtual standard switch 1. So, and obviously when you create a virtual standard switch, 1 port group will be automatically there, because virtual machines need to connect with networking. But the benefit of creating a new network or new standard switch, what is the benefit of creating a new standard switch? So on standard switch level, you can attach newer network adapters. Standard switch level, you cannot attach network adapters to port groups, right? You can attach network adapters, new network adapters, to another standard switch, just to separate the traffic. Obviously, you can add many network adapters to this standard switch as well. 4 network adapters, or all 10 network adapters you can assign to one standard switch as well. But if you want to separate out the traffic, then you can just create a second standard switch, and that second standard switch, that second standard switch will connect to another set of network adapters, and suppose then that virtual machine traffic, so virtual network card connects to the port group of the second standard switch called VSS1. That second standard switch connects to a separate set of network adapters. So the whole traffic of this virtual machine is totally separate within the same hypervisor. This machine's traffic does not touch this machine's traffic. Although if through the outside physical adapter, suppose both pair, this pair and this pair, suppose they're connected to the same physical adapter, then obviously they can still share data. But even if the outside physical adapters are separate for them, then obviously they can't share data between each other. You have totally separated the whole traffic while the virtual machines are living on the same physical hypervisor, right? So this is how you can use second network adapter as well. So let's create the second network adapter and assign it to separate new physical adapters, right? So we'll create, and then we're gonna add one virtual machine just to the port group of second standard switch. So I'm gonna go back here, and so yeah, one vSwitch 0. If I just collapse this, so yeah, there's just one switch here, right? Okay, and I'm gonna go to add networking to add a second standard switch and assign two new network adapters to the second standard switch, right? Okay, yeah. So once I'm done with this, then I'm seeing the chat as well, and there are some T-shoot going on there. So yeah, once I finish the topic, then I'll connect to that machine. O and K. I need to add the second network, second standard switch. So I'm going to go to add networking here, and I'm going to go for the same second option with which I have created a new port group. With the same second option, I'm going to create a new standard switch, right? So I'm going to click next, but this time I'm going to go for new standard switch. So MTU, or maximum transmission unit, is just the payload of the packets that if in special circumstances you want to change that value, then you can change. Otherwise, we normally keep it as is and do not touch it. So I'm going to click the new standard switch and next. Now it's asking, oh, so you want to connect, you're creating a new standard switch. Now you have to select the separate set of network adapters. So obviously the second standard switch cannot use the network adapters of the first standard switch or the adapters that were assigned to the first standard switch. So I'm going to click plus sign here. We can't even see VMNIC 0 and VMNIC 1, right? They're being used by the standard switch 0. So this is standard switch 1. I'm going to assign two separate. So I press the control button and then selected both two network adapters next to available and pressed O and K. So it's the same way I assigned the two network adapters to the first standard switch. Now, same way I'm assigning the two adapters to the second standard switch, virtual standard switch. Oh, okay. Next, yeah.
How do you select both?
Yeah, back and plus one is already selected, right? So press the control button on the keyboard, keep it pressed, and then select the second one. Right, keep the control button on the keyboard pressed, and then O and K, and then just press OK. And now next. Remember the naming convention here. So this port group, this is a port group that is getting created automatically. We need to name the port group. We know that it doesn't belong to, this port group belongs to VS1, not VS0, right? So VS1 automatically standard switches are named 0, 1, 2, 3, 4, right? And we cannot rename the standard switches. So VS1 dash PG dash, suppose it's the IT department related virtual machines will be connecting to that. We can just name it anything. So we're pretending it's still belongs to another department. Now, once we have put that name here, then click next. Next. Yep. And so we're creating a new standard switch with its default port group. Okay. So guys, everyone, please mute your mic. Thank you. Okay, here. So if I go up, I'll collapse this 0. Collapse. So now you see vSwitch 0 and vSwitch 1, right? So if I expand the vSwitch 0, yep, that has 3 port groups. And if I expand vSwitch 1, which is at the bottom, I'm going to expand that now. This has 1 port group, and the port group name is according to the standard switch that it's connected to. It's connected to vSwitch 1, so it's VS1, right?
Which one is the VLAN ID?
No, you want to change the VLAN ID, it's okay. Otherwise,
is it 0 or we leave it at 0?
Yeah, we leave it at 0. Yeah. Okay. So here, now we can just move the first machine that was on the default port group of standard switch 0. We can move that machine to the port group of virtual standard switch 1, right? So I'm going to go there. We'll pretend that this machine belongs to IT department, and I'm going to right click the machine. It's the same thing, right? So go down to edit settings here as well. Then the network adapter of this machine is connected to the port group, which is the default port group of standard switch 0. I'm just going to go down, browse. Now I should see, yep, we can see the new port group of the new standard switch, VS1 PGIT. I'm going to select that because they are on the same hypervisor. So no problem connecting this machine to the port group of another switch, standard switch, right? So I'm going to press OK and press OK again. Now we're going to check out how does it look like. So I'm just going to go to the hypervisor level and then configure hypervisor, configure under networking, virtual switches, right? And if I go further down here, this is vSwitch 1. And I want to see the port group of vSwitch 1. It should have 1 virtual machine now, right? If I go there, this is standard switch 1. Yeah, and yes, it has that virtual machine that we attached to it. So vSwitch 1's only port group called VS1 PGIT has 1 virtual machine now attached to it. And it also shows 2 physical adapters because when we were creating the standard switch 2, at that time we added 2 physical adapters, right? Or you could have added first just with 1 and then added a second one manually, or 2 more network adapters you want to add, or whatever number of network adapters you want to add. You know the way. Just go to the manage physical adapters and just keep on adding whatever number of physical adapters you want to add. So now we get that. If we go to the diagram here, so we can separate the traffic between the between the 2 standard switches, and the traffic could be totally separate as well. If even outside the physical network adapters are connected to the separate physical switches, so it could be totally separate traffic as well. And also that we are not overwhelming the 2 network cards with all the virtual machine traffic. This virtual machine is connected to a separate standard switch, which is connected to 2 other network adapters which are only handling the traffic, right, of this virtual machine. So these adapters have some pressure relieved because of the extra 2 network cards added, right, to the standard switch. So that's how we can play with the settings here, and there's so much flexibility here. But then we need to also check what's under the hood. What does that mean? I mean, okay, we can create standard switches. Yeah. We can create port groups. Yep. And we can attach, detach virtual machines to different port groups on different standard switches. Yep. And we can add physical adapters. Yeah. But what's inside a standard switch? Are there more features in the standard switch? And also, are there more features in the port group? Other than that, yes, it is used for organization. Yeah, we're separating the virtual machines as separate departments. Does it do anything more than this? Yeah, it does much, much more than this. What is that? But first, let's go inside the settings of virtual standard switch. Okay. So here, there's an edit button here. When we click the edit of standard switch vSwitch 0, then this portion comes, right? So first of all, obviously, we don't need to change the maximum transmission unit here. Second thing is it shows here number of ports, elastic. So normally a standard switch will have 128 ports it will offer. So elastic just means that automatic, that if suppose there are 2 virtual machines, so 2 ports will be offered. When I say ports, if I go back here, so you can see that, sign here, the blue one, or the green one. What's wrong with me? So those are the signs of the ports, right? So a virtual machine is assigned 1 port here, right? And if I expand this, if suppose there were 3 virtual machines here, so there were 3 ports showing. Right now there is 1 port showing, this one, right? So, here, I'm back to the same mess. Hey, what was I talking about? Yeah, I guess I was here, right? So these are the ports here that we assign. So I'm going to go inside edit, inside the standard switch. I'm going to show the features, what else it has. So yeah, elastic just means more machines come. Suppose there are 10 more virtual machines that you create, automatically or elastically, they will be assigned ports from the switch. That's what it means, right? There's that security related stuff here, that promiscuous mode, MAC address changes, forged transmits. Promiscuous mode means that more detailed traffic can be produced, so you could catch those packets through sniffer. Anyone knows a sniffer application? Any famous sniffer application anyone knows the name of?
Wireshark.
Wireshark.
Exactly, Wireshark. So you should also try to use sniffer tools like Wireshark and others. But through Wireshark, you can catch the packets. So suppose if it is enabled or accept, then whatever traffic is leaving the switch, there will be more diagnostic data available in those packets that could help let us know if there are any issues going on. Suppose there's a data being dropped, right? So if you want to release more diagnostic data, then you enable that. Otherwise, obviously, it's going to add to the network traffic, and it's going to slow down the traffic as well. So just for diagnostic purpose, you want to add more details to each packet, then you can try to know what's going on when you catch the packets with the sniffer tool. Okay. MAC address changes, if there are, so every machine, virtual machine has MAC addresses, and do you want to allow MAC address to be changed for a virtual machine? Normally that is used for load balancing and those unicast, multicast load balancing. In special circumstances only, you would change it to accept. Otherwise, normally you don't want MAC address changes to happen for virtual machines, even if they are behind the load balancer. Forged transmits, again, is if there are any MAC address changes happening, or a forced transmit would be just that a traffic is going on, and it looks like it's going from one virtual machine, suppose VM01, but it's actually coming from some other virtual machine. Are you allowing this to happen? You can only allow this happen, suppose you want to test your own tools, then you would let forged transmits to happen. Otherwise, it's not necessary. And normally you would see that administrators would not really change this unless there's a special reason for that. Traffic shaping is that status. If you enable it, so traffic shaping basically is you do not want, suppose you do not want during peak hours the traffic to be more than, so the data kilobits per second, so this is like 100,000, right? 100,000 kilobits per second. Traffic should not be more than 100,000 kilobits per second. Suppose it reaches 200,000 during peak hours, like between 10 o'clock, 10 a.m. till 2 p.m., right? So suppose during peak hours, if it is um, 200,000 kilobits per second. So suppose it slows down the rest of the traffic for all the other virtual machines. So maybe your virtual machines connected to this particular standard switch are using more bandwidth than others. Then you can put a cap on that by enabling that and then changing the numbers that don't. If you enable it, obviously, then there are numbers already recommended by VMware that the traffic or bandwidth should not be consumed more than this much kilobits per second. So this is just putting a cap on that peak bandwidth. Majority or max bandwidth should be this, not more than that. If you enable that, and then I'm going to disable that. And then burst size is just for the packet, that what kind of payload a packet should take, and the traffic could be or set of packets. This is collection of packets with this much burst size, or having this much bandwidth or size of traffic is allowed, not more than that, in bursts when the traffic is sent, right? So the thing is that if you want to put a cap on huge traffic during peak hours, then you enable that. Otherwise, you leave it as is. And then there is teaming and failover, which is load balancing here. And load balancing, there are more options here as well. So if I take this here and paste it here. So now route based on originating virtual port, this is by default selected, but there is route based on IP hash, route based on source MAC hash, and use explicit failover. So suppose there are virtual machines here, and those virtual machines are connected to a standard switch here. And standard switch is moving the traffic to these NICs here, right? These are all virtual machines, VMs. This is virtual standard switch, and these are phi NICs, physical NICs, right? These are physical NICs, right? So what happens is that with suppose you've selected route based on IP hash. So what happens basically is, suppose this virtual machine, the first time, the first day when it send the traffic to the standard switch will select randomly a network adapter here. Okay, you get that traffic. So this network adapter remembers the or caches the IP hash information, or what was the IP address from which the traffic came to me. It saves that, and the next times the traffic comes from this virtual machine. If it comes from this virtual machine or goes to this, it will always go to this network card until it is overwhelmed, and then it will distribute the traffic to other network cards as well, right? So if, and that's the same thing with, if you select the source MAC hash. So suppose, and it's the same story now, that first time this machine sent a traffic, and virtual standard switch randomly selected this network adapter. So this network adapter would cache or remembers the MAC address of this virtual machine from which the traffic came the first time, and always from this virtual machine to and from, whatever traffic comes and goes will always hit this network adapter. Whenever it has too much traffic, it will just share that traffic with other network adapters to load balance it. And this originating virtual port, this is by default there, that whichever virtual port it is connected to. So remember that all virtual machines are connected to a port here, virtual port on the PG port group connected to the virtual standard switch. There are virtual ports here. So if the first time a virtual machine sends, suppose this is selected, and a virtual machine sends through a specific virtual port. So this is port 1, this is port 2, this is port 3, and suppose the virtual machine is also connecting to the port group. Port group offers a port 4, right? And normally maximum it has 128 ports, right? So this is port 4. So whichever virtual port the traffic on day 1 uh, came to the standard switch, and standard switch randomly selected a network card. Okay, you will handle the traffic. So it will remember that virtual port, and whenever next time the traffic comes from that particular virtual port, it will always go to that network card unless it is overwhelmed, and it will share the traffic with other network cards. And then there is a fourth option, which is use explicit failover, where um, use explicit failover, which just simply means that virtual machine will send the traffic, and that traffic, all traffic to the port group, to the standard switch. Standard switch will randomly forward the traffic to any of the network adapters. If any one network adapter goes down, then failover happens, and all the traffic going to that network adapter will be redirected to other network adapters. So that's this explicit fail over. Okay. So that is what it all means. So we can keep it the default virtual port setting. Then there is network failure detection here, and there is link status only and beacon probing. And that is oops. Beacon probing is that, suppose you have here, hypervisor ESXi, and then you have here two samosa, I mean like two network cards, right? Or multiple network cards here. And then you have here a physical switch. This is phi switch. This is physical switch, not virtual switch, right? And then there are more physical switches here as well, suppose. physical switch, right? Physical switch 1, 2, uno, dos, tres, right? 1, 2, 3. So here, what happens is with this option, link status only. So if this network card is connected directly to the port of this physical switch here, and there is this network adapter that is connected to second switch directly, that is, and if the first one, it goes down, so link status, this option just lets the standard switch know that, hey, the direct link is down, this one. So don't go this one, just send the traffic through this network card to the other switch, right? Because that direct link is down. So link status only gives the direct link status. Is it up or is it down? But then there's beacon probing as well, right? So there are further connections here. Obviously, the physical switch is connected to multiple physical switches, right? So suppose there are multiple switches here as well. So beacon probing is that it sends packets, and not only that, the direct link status is updated, and information about that link is updated to the standard switch, but it also probes that, hey, the extended link here, are they also up or not? So suppose this is also connected here, and or those links are up there or not. So suppose like this one. Oh, okay, I don't want a big rubber like that. Okay, this one is O and K, right? And so the extended, so the direct link is okay, but the extended link has some issue, right? Extended link is gone. So beacon probing is that it checks the extended network. Okay, I am connected with this direct switch, but what about the rest of the connections after those switches? Which link is down with and which is not? So beacon probing just probes the extended network and then updates the switch that, hey, you don't send the traffic try to send the traffic to this switch, because through this switch the traffic is going outside, but through this switch, extended network is not good, or send to this switch and it should go to that switch from here. That is good. So beacon probing just simply gives details of extended network to the virtual standard switch, right? If I go back here, so yeah, link status only is default. Notify switches, obviously it's a yes. We don't want to say no to that. Obviously switches need to be notified if there's a problem with the connections. Fallback is just that if suppose this physical network adapter is down, then all the traffic will go to this network adapter, right? And when this adapter comes back, actually the example would be better this way. There's a standby here, and then there's a active one. Active one suppose goes down, and the standby becomes the new active one, right? So when suppose the 0 which was down comes back up again, do you want to fall back, which means that demote this to standby again and put all the traffic back to this one which crashed temporarily and then came back up again? So fallback just means that whatever crashed, if it restarts again, yes, then the new one demoted again to standby, and old one put the traffic back there. The default setting is yes, fallback. So these are all the failover order as well, whichever you want to failover from which adapter to which adapter you want to failover. You can put 0 here and 1 here, and then obviously whatever is in the standby will failover if whatever is in the active is gone, right? So these are all the features that we wanted to I wanted to show you as well. Properties, security, traffic shaping, teaming, and failover. If I cancel out from here, so these are the features inside the standard switch. So not only that, you can create multiple standard switches and create port groups on the standard switches, but also inside the standard switch, you can also make changes. But if I go inside a port group, any of the port group here, so I select the port group and then I go to the three dots here for the port group, anyone, and then click edit settings, edit settings, edit settings. Okay, these are the settings of the port group. On the port group level, remember that on the switch level, standard switch level, you see a MTU. On the port group level, you see VLAN ID, right? And second thing, if you go to security, it's exactly the same options, but with an override button. So that's a pretty cool thing. Suppose you have multiple port groups, but you want to only investigate traffic for the virtual machines on a particular port group. So you can enable promiscuous mode only on that port group instead of on the edit switch level, which means all the virtual machines of all port groups will have diagnostic traffic, which means that more bandwidth will be consumed and the network will be slowing down, right? So all those options are exactly the same on the port group level, but with the override button, that whatever settings from the standard switch, do you want those settings to be in the port group? Or for each port group, you want to have separate settings other than the settings on the standard switch, different from the settings of the standard switch. So each port group has the same options, but with the override option. So switch level, standard switch level settings are there. Same settings are on each port group as well. They're there, but with the override option, right? So you could change it on any port group level for any particular port group because of whatever the virtual machine settings are there, right? ONK. So, okay, so that's overall what we wanted to discuss with the virtual standard switch. There is that break time here that we can take, right? So we can come back after the break and then continue. So we do need to talk about another topic, which is migrating virtual machines. Okay, so there are some points to understand here for migration of virtual machines. That why do we need it, and how many types of migrations are there? So if you go to the diagram here, I'll open a cleaner one. I'll check if I have something cleaner than this. Okay. So now this diagram where you can see that we have our vCenter virtual machine or VCSA deployed on ESXi1, right? And we have SAN, the 3 disks that are LANs that are there connected. right? And we have created data stores on top of these LANs, which are shared disks over the network, right? Now, well, this just for the understanding of the map, I explained that. Now we're talking about vMotion, which is migration of virtual machines from one hypervisor to another. Okay. Now, why vMotion is so important? If there is one virtual machine here, so suppose this is the virtual machine on this hypervisor ESXi2, right? And that hypervisor, now there are obviously in one hypervisor, there would be as many virtual machines as comfortably we can put there. There would be as many virtual machines here. Like suppose if the hardware of this physical server is very good, it's like 36 core vCPU or 1 TB, 2 TB RAM, and terabytes of SSD, hard disk, huge storage as well. So you could put here 15 to 20 virtual machines even. So these virtual machines, when during peak hours, obviously, suppose there are 2,000 users here connected, and 1,000 users here connected, and 3,000 users here connected, and 700 or 600, 500 users connected here. So that's a lot of traffic. And during peak hours, like maybe from 10 a.m. till 2 p.m. or 3 p.m., there's a huge amount of traffic going on. Everyone is opening, closing files. And oh, there's a comment in the comment section. Can you please open the mid-exam questions and answers as it's still locked? What is that? I mean, were you not able to do that? Or we can, well, we have started this and there is a bit bigger lab here. So guys, do you want to talk about exam, or shall we go with the practical and lab? Or I'll continue. Yeah. Okay, the labs. So yeah, what we were talking about here, there's a physical server and it's having peak hours. So in peak hours, obviously, the CPU and RAM will be always, every virtual machine will try to take over the CPU and RAM, and every virtual machine will be requesting more and more CPU and more RAM. It's always the competition going on, right? So suppose there is and uh, uh, so what happens is, okay, what happens is that during peak hours, if the CPU and RAM is overwhelmed, and it's suppose it's 88% CPU and RAM is already used, right? So what happens is that all virtual machines, all users on the virtual machines that are connected will start complaining that, hey, we are opening files and the files are, the users are connected here, users connected here and here, right? In all virtual machines. Overall, the virtual machines will, some virtual machines might have more CPU and RAM and some may have less CPU and RAM, although they need more. So in that case, what will happen is that, the users will start complaining, and then you as a VMware administrator, you will come and check, and then you will realize that, oh, there's that CPU and RAM that has reached 88, 90% during peak hours, and there are users complaining of slow virtual machines there, or slower opening of files, slower closing of file, or saving of file, or creating of file, right? Then you realize that the other hypervisor that has, so this has 88% RAM used, right? and other one has 60% CPU RAM used, right? CPU and RAM used 60%. So you see that you as a VMware administrator see that, oh, there's a lot of RAM here available. 40% more CPU and RAM, 40% CPU and RAM is available. Here it's just 12% CPU and RAM available. So you decide that you want to vMotion the virtual machines from this physical server to that physical server. So you decide that, okay, the machine with 3,000 users would be, this machine has most users. So you want to migrate then this virtual machine from this hypervisor to that hypervisor, right? But how would you migrate that virtual machine? One way is that you shut down the virtual machine. You tell all the users, okay, I'm about to shut down. Please, everyone disconnect and then reconnect again when once the machine is up and running. So one way is that you shut down the machine and then migrate the virtual machine files from one hypervisor to another. But there's a downtime there, right? So vMotion, the ideal situation is that with least amount of disruption, you can move a virtual machine from the slow performing hypervisor to a fast performing hypervisor with minimum amount of disruption or downtime, right? Or no downtime. So that is not an option that, or that is not something that you would prefer, that I would shut down the machine and 3,000 users will stop working and they will keep on waiting until the machine is migrated here to the other hypervisor and then start it, right? So um, the other way would be that while users are working here and the machine is powered on, they are working, and you're able to move the machine from one slow performing hypervisor to the fast performing hypervisor. And the user experience will be that, first of all, it will take few seconds for the machine to migrate. Second thing is the end user experience will be that they will be, while they are working and while the machine is migrating, the user screen will freeze for those few seconds. Click, 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 click. User will do that, and there will be no response, and user will see that, oh, it's frozen. And all of a sudden, in few seconds, uh, again, the file is opening, or file, whatever the user was working on, user is able to work, but this time it's faster now. So machine has migrated here, and then after that, well, user would not know that the users are connected, they are working while you migrate the machine. While the migration is happening, few seconds, the user screen will freeze. User will be click, 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 nothing happening, and they're thinking of calling the support. All of a sudden, it starts working again. So they don't know that in the background that the whole virtual machine with the users and their connection information was migrated, moved from one hypervisor over the network to the other hypervisor. And as soon as it reached this hypervisor, um, you know, because there's more CPU and RAM available, so that virtual machine is, or the users in that virtual machine are now okay and they're working fast, right? So Nuruddin says in the chat, is vMotion automatic? Then how does it determine which VMs should be migrated to a new hypervisor? So right now we're talking about the manual vMotion. Automatic vMotion is DRS. The other name for that is DRS, Distributed Resource Scheduler, that automatically migrates vMotion. So when we come to that topic, DRS, and that is part of the cluster. So when we create a cluster, then there will be DRS, there will be high availability, and there will be fault tolerance. All those features will be available. Then we will discuss that. But DRS automatically, yes, DRS automatically decides. Since we're talking about automatic vMotion, so right now we're talking about manual vMotion, that we as a VMware administrator will connect and then we will migrate manually. But DRS, it checks every 5 minutes which hypervisor has CPU and RAM, 80, suppose it's 88%. So it checks that. And the other hypervisor has more CPU and RAM available. So there are levels of decision. There is aggressive level that if there is a slight difference of CPU and RAM, migrate right away. And there are levels where if there's a significant difference, like if it's 88% and this is if it's on 50% or 40% usage only and 60% is available CPU and RAM, only then migrate. So we can configure this DRS on 5 different levels, where either you migrate even if the slight CPU and RAM is available more, then migrate right away. It will automatically migrate to another level of DRS where if it is a big difference only, then migrate. But it does it automatically, and we're going to talk about it, and we're going to do a lab on that as well. But it automatically does all that. It does the calculation every 5 minutes. It keeps on checking. Oh, this has less CPU and RAM available. Oh, this has more CPU and RAM available. It just migrates automatically itself. Determination is that it determines by calculating every 5 minutes which CPU, which physical server has how much CPU and RAM available. Okay, we're talking about the manual migration right now because that must be working fine for the DRS feature to work, which is an upcoming lab later in next classes. So right now, how manual vMotion works and how do we configure the manual vMotion? So first of all, the scenario we talked about that you realize as a VMware administrator that there's less CPU and RAM available here, and you decide to move one or two virtual machines or more to the other hypervisor, which you see that it has more CPU and RAM available, right? And then you migrate a working virtual machine where users are connected, they are working, and you migrate that virtual machine over the network from one physical hypervisor to another physical hypervisor. So how is that happening technically? And there are a few things to understand here. One is that the disk, the virtual disk, this one, virtual disk is always heavy, right? For every virtual machine, there could be 50 GB of data there. There could be 100 GB of data. Maybe there is 200 GB of data. So in vMotion, the virtual machine memory contents only move from one hypervisor to another. The virtual disk never moves. So that's one thing to understand. Now, how is that possible and what's going on in the background? So virtual machine memory contents is what? The virtual machine files other than the hard disk, which are less in size, and the information about how many users are connected, how many connections are there, and what files were open, what files were closed, which is also a very small sized information. Heavy data is in the virtual disk, which doesn't move during the vMotion. So virtual machine memory contents are all saved on the RAM. How many users are connected, virtual machine is up for how long, how many connections are opening a file, how many connections are saving a file. So all that memory content doesn't take much space there. So that memory content only travels from the RAM of the source hypervisor to the RAM. So I'm gonna write here CPU and RAM to the RAM of the target hypervisor. So memory content only travels during vMotion from the RAM of one hypervisor to the RAM of the other hypervisor, while the virtual disk itself, that file never moves. So if that heavy file, suppose it's 100 GB, 90 GB, 200 GB file, if it had to move, it will take several hours, and the performance that the end user will see will be unacceptably slow, right? It will be unacceptably slow because a very heavy disk will be moving. If it is moving, then there is no benefit of having a vMotion. If the virtual disk or the heavy data has to move. So the point here for vMotion is that heavy data never moves lighter data moves. So how is that then possible? When the migration, when you decide to vMotion, you click the wizard, right click, and then click the migration, and then click next. As soon as you click finish, so what happens is, remember that this lawn is attached to this hypervisor. It is attached, the same lawn is attached to this hypervisor, and the same lawn is attached to this hypervisor as well, right? So the data stored on top of the lawn obviously is also accessible from this hypervisor. It is, the data store is accessible from this hypervisor. The same data store is accessible from this hypervisor as well, because it is on top of a LAN that is attached to all three hypervisors. Same LAN is attached to all three hypervisors, right? So this means if so, virtual machine memory content travels from the RAM over the network to the other machine. As soon as it reaches here, so it was connected to this data store to its virtual disk through ESXi2. As soon as it reaches ESXi3, there's a cutoff time. It cuts off and at once makes a connection through ESXi3 to the same LAN, to the same data store, back to its disk. Because, as I said, the same LAN is attached to ESXi2, the same LAN data store is attached to ESXi3. So this virtual machine can access its virtual disk from ESXi2, and this virtual machine can access the same virtual disk from ESXi3 as well. And whichever, suppose there were 200 hypervisors here. If this LAN was attached to 200 hypervisors, so whichever hypervisor this virtual machine jumps to, from that hypervisor, it can make quick connection to its virtual disk again, right? So that's the benefit of SAN storage, or over the network shared storage, that this storage is attached to this hypervisor, same hypervisor, all same storage is attached to all the hypervisors. So virtual machine can actually jump to any hypervisor while maintaining its connections to its heavy virtual disk, right? So this is the logic behind what's going on. And virtual disk never travels during the migration. Only memory contents of the virtual machine, which are less in size, only travel during the migration. And virtual machine was connected to its virtual disk through ESXi3. When it reaches ESXi2, so when it reaches ESXi3, it disconnects its connection through ESXi2 to its disk and makes a connection through ESXi3 to its disk. So the users are always connected and their data is connected, but now the virtual machine has been loaded to the RAM of the ESXi3, which has enough CPU and RAM available. This means that the virtual machine performance will be better, because it has now more CPU and RAM available in the underlying hardware, right? So that's how virtual machine makes a vMotion just by not moving the virtual disk, but moving the just the memory contents of the virtual machine. So if you need to move the virtual disk, yes, you can do that too. But obviously, this means it's a heavy thing that you're moving over the network. So, but you can move the virtual disk from one data store to another data store. You can do that too, and we're gonna do that. So I will show you that too, how to do that, right? So this is how this whole vMotion really works. If I go to the diagram here, or not diagram, but the slide, there's a code migration where virtual machine is off, and it could be migrated from one hypervisor to another hypervisor. It's off, right? And so virtual machine power state off. If it is off, can you migrate? Yes, you can. And does it need shared storage? If it is off, no, it doesn't need shared storage. Or if, which means basically that if virtual machine was created on the local disk based data store, and you want to migrate the virtual machine, turned off virtual machine, powered off virtual machine from one local disk based data store to another local disk based data store across the network, yes, you can do that if it is off. If it is on, then you cannot do that. Then you must have shared drive over the network or LANs based data store for the virtual machine to migrate, because in that case, virtual disk doesn't move, only virtual machine memory content move, right? So cold migration, if the machine is off, you don't need SAN there, and different CPU families allowed. Whoa, what is this? CPU family different? What has CPU family to do with migration? So let's understand that too. And I made it too messy, and the World Cup. Okay, let me grab that diagram again. Okay, so what about this thing called different CPU families must meet CPU compatibility requirements? What is this? And what has this to do with migration? So what happens is that that's it. Oh, well, it was, yeah, it looks messy as well, but that's a genuine one. That's a new one. Okay, so CPU family has to be same. What does that mean? If we talk about migration, so suppose this physical server has Intel based processor or CPU, and this one has, what is the other one? Anyone knows the other famous brand? Who?
AMD.
Exactly, AMD. So AMD based processor or CPU is there. Suppose that's the case, then there cannot be any migration. And reason would be that, the virtual machine is sending requests at a certain speed. There's a synchronization going on. People are opening, closing files. So that request goes to the vCPU. vCPU give it to the hypervisor. Hypervisor sends that request to the processor here, physical processor core. And there's a, through a certain synchronized speeds, it's going, the requests are being handled and implemented. So AMD would run on a separate type of speed, separate cycles, core cycles. Their processor cores would be running at different speeds which are not synchronized with that. So if it migrates from here to there, machine would be unstable. So if there are different processors, different manufacturers for the physical hardware, then vMotion cannot occur, right? vMotion is not O and K. If, oh, I have to remove that too. If both physical hardware are from the same manufacturer in terms of processor, but different gen. So this is suppose Gen 3 and this is processor Gen 11. Even then, vMotion will not occur, because again of the processor architecture. The difference between the processor architecture affects the working and accepting and of requests, and the speed with which the requests were being processed by a different architecture based processor. When it reaches the other one, it has different processors. Maybe it is even much more speedier, and this makes this machine actually unstable, that the way it was working before, at once the speed changed. So that does affect the machine and rendering it unstable as well. So if processor generation is different, processor family is different. Suppose this was purchased in 2019, right? This physical server, and at that time it was Gen suppose 7, right? And then it's there was no budget on 2020, 2021, 2022. Now 2023, company decided to purchase another physical server, but that's now with a totally different processor architecture. Although same manufacturer, but processor family is different. So in that case, obviously vMotion will not happen. So the thing is, it has to be same gen as well. So it is, suppose Gen 7 here, suppose it's 7, so it has to be same family or generation as well, same processor family or generation. That is a must for the vMotion to occur. So that's why when VMware administrators are purchasing hardware, they always make sure that it's pretty much the same hardware. If it's slightly different, at least it should be exactly slightly difference only, not big difference in processor architecture. Okay, so that's where it says that if the machine is turned off, even if they are different CPU families, it's okay. Like it's turned off, so it's not working. There is no processing going on. So even if it's AMD and if it's Intel, it's okay. It will migrate. But in a suspended state where it is frozen, like powered on and frozen, right? Or it is on, the rest of the three are, it is powered on. So must meet CPU compatibility requirements, and I gave you the requirements already, that it has to be the same processor family for the vMotion to occur, and just the same manufacturer and different processor family also will not work for vMo and Shun. Okay, there's a question in the chat. Dell and HP, same gen CPU. It because okay, suppose it's Dell. This physical server is Dell, and this physical server is HP. As long as suppose they both created those their own physical servers in the same year. Suppose it was 2023. They both manufactured, and obviously either they can use Intel processor, the server Xeon processors, right, or AMD processor. So if it's the same year and they contacted the same processor manufacturer, and if it happens to be the same processor family, because Intel would release in certain year the same processor family, unless there are requirements of HP. No, my physical server will have much more powerful, different family processor. Then it will. So the main thing is manufacturer. If they both contacted the same manufacturer and it was the same gen, and most it could be possible that it could be the same gen. Yes, then Dell and HP are also okay for vMotion. If they are different gen, then yes, they are not okay. Whether same manufacturer or the same different company, but same manufacturer, right? So the thing is, it is possible that HP and Dell could be ordering the same, same gen CPUs in this. Is suppose it was the same year. So yes, VMware administrator have to see what gen, and that is pretty easily we can find on the model of the physical server that we're about to purchase. We can just check that, and then we can order that. So yeah, the manufacturer could be physical server manufacturer could be different. If and the Intel processor could be from the same gen, then yes, it will work. O and K. And there is suspended. If it is suspended, yes, suspended virtual machine can be migrated, but the processor should be belonging to the same gen on source and target physical server. And then there is vSphere vMotion that is powered on virtual machine. Yes, host to host migration is possible. Host or data store migration. Data store migration is that the virtual disk also moves from one data store to another, while virtual machine moves from one host to another. So in a diagram, it would look like that the virtual machine is moving from one host to another, and its virtual disk is moving from one data store to another. So that is also possible in one wizard, and we're going to do that too. vSphere storage vMotion. So storage vMotion is the same as virtual machine vMotion. Here, the storage itself can migrate if it sees, suppose that this data store free space is very, very less and it's about to fill up, so it can migrate to another data store. So that is also possible. And then cross-host vSphere vMotion, this just means that both cross-host vSphere vMotion, that you migrate virtual machine from one host to another, and that same virtual machine's virtual disk from one data store to another. So that is also possible in the same wizard. O and K. So we talked about the vMotion, the logic of it, and some requirements of it as well. For the benefit of the time, we need to start the lab as well. But what important theory we needed to discuss is discussed. There are some processing architecture related things that I will be uploading this slide, and then you can see that the architecture related deep down conversations are shown here if you're interested. Otherwise, the main points I've already discussed here. We can just go with the lab here, and obviously lab prerequisites have to be met. So the first prerequisite is our CPU requirements are okay, as we have same CPU for our both hosts. So are the CPUs for our lab the same? Yeah, I mean, that we can safely say yes. And then let's confirm our network settings. It has extra switches and port groups. Then let's delete it. Yeah, we don't need, we need the, we need to remove the mess from the last lab. So we will delete the extra standard switches, and we're going to make the same configurations like this. E6i3 has just one standard switch and one port group. So we need to put everything back to the same in E6i2. Here we created two standard switches, we created three port groups. We're going to remove all that. So let's remove that quickly to clean up our environment. And then we're going to go for the next prerequisite. So I'm in E6i2 now, and I need to remove whatever I added. So first thing, I will collapse this standard switch. So vSwitch 0 is there, vSwitch 1 is there, right? I need to delete the vSwitch 1. I don't need that now. So vSwitch 1, not vSwitch 0, right? vSwitch 1 is there, and then I go to the right side. There are three dots here in the line of vSwitch 1, and there is the remove button. This one, three dots, remove button for vSwitch 1, not 0. So I click remove, and it says, hey, you want to remove which one? vSwitch 1. Make sure it's not 0 here, right? And then yes. So vSwitch 1 is gone. Now I see only vSwitch 0, right? So I'm going to expand that, and I don't need extra port groups here because I want to keep the same configuration as E6i3. So I will quickly move all the virtual machines to default port group VM network from the other port groups, right? So I'm going to go to the machine 1 quickly, right click it, edit settings, and yeah, network adapter of this virtual machine was connected to another. So I'm just going to go to the default VM network, which is the default port group of standard switch 0, right? So all machines, I'm going to do the same thing. Okay, go for the second machine, whichever other port group it was attached to, I'm going to attach it back to the default port group of standard switch 0. All right, so browse. VM network. Okay. And then go for VM02. Edit settings. Oh, my youngest son is also doing that. Okay, so here, VM network. Okay, so we get that too. Right? Now all three machines are away from the rest of the port groups to the default port group. I'm going to go and remove the default port group. Okay, so I'm going to delete this, not the default port group, but the other port groups, which is VS0 PG MKT. So 3 dots here for the port group, remove, right? Straightforward, pretty straightforward stuff, right? And then VS0 PG sales, not the VM network, right? VM0 PG sales, yes. So removed the port group as well. And I had added an extra physical adapter to this, which is not added to the standard switch of E6i3. E6i3 has a default one physical adapter. So I'm just going to remove that second physical adapter from the, that's it. Okay. What? Can't even see that. View settings.
Are you removing VS1 PGIT?
VS1 was removed already when the standard switch was removed.
The PGIT one?
Yeah, that was already removed automatically because we removed its standard switch. So its port group also got deleted with it. So here, physical adapter I need to remove. So I'm just going to go up to the manage physical adapters. I'll go up to the manage physical adapter, and there's that adapter VMNIC1. I'm going to select that and put the red cross here, right? So now there's the default physical adapter only remaining with the standard switch vSwitch 0. That was the default setting, and that's the same setting for E6i3 as well. So now E6i2 standard switch setting and E6i3 standard switch setting is the same. Whoa, what is this? Did I do something wrong? There's a red sign here. If I go to summary, oh, redundancy. It says that, oh, your management network was redundant. Now it's no longer redundant. We're saying, okay, no problem. Like redundant means there should be two. So we did not follow the recommendation. So that's why it's giving an error, but everything is okay and working fine. So I'm just going to reset to green after seeing this error. Reset to green. That's it. Error red sign is gone. Okay. So it's on summary. Okay. So let's go for so the E6i2 network setting is this. If I go to E6i3 and configure and virtual switches, obviously it's the default setting. One VM kernel port and one port group here with one physical adapter in the default vSwitch 0 for E6i3. And E6i2, if you click that, it's the same thing, right? Now we have E6i2 has just 3 virtual machines, which is okay. If E6i3 has none, no problem. Now, let's go for the next set of prerequisites. So it says, let's create a new VM kernel adapter port group with the same name on both hosts, vMotion, give it to physical links, create it on server, new vSwitch 1. So yeah, what it's saying is, and we're going to follow a best practice that I wanted to show you. And that best practice is that we're going to set up vMotion on a separate standard switch with its own set of network adapters, right? So there's that switch, vSwitch 1, VS1, we're going to create on both sides. On both sides, we're going to create VS1, and then we're going to create two network adapters separately dedicated for VS1. So we're going to create a separate standard switch, and we're going to dedicate it. We're going to give it dedicated network adapters, and it's that switch will only contain the vMotion traffic. Although we can configure the vMotion traffic on the same switch, but just following the best practice because we have extra network adapters, right? So this switch will be dedicatedly only handling vMotion traffic, right? So how to configure that? We're going to create a new switch. We're going to create a new VM kernel adapter, and remember that VM kernel adapter or VM kernel port, we can also say, is it helps, it offers networking services for advanced features like vMotion. Now we're configuring, so we're going to create a VM kernel adapter for that, right? So what I'm going to do is I'm going to go here and I'm going to go to VM kernel adapter this time, this one. We already know that there's one VM kernel port or VM kernel adapter added here, and that is for management network, which helps us remotely connect to this hypervisor. So it's necessary, that's why it was created already for us, right? But now we're going to create vMotion. We're going to configure vMotion on this hypervisor and this hypervisor both. So how do we configure that? We're going to go to VM kernel adapters and we're going to click add networking, right? And since we are adding a new feature called this one, right? vSphere vMotion. We're going to configure this feature called vSphere vMotion, right? So for that purpose, we will keep this selected, the first option, VM kernel network adapter. Next. And we can configure it on the existing standard switch, or we can configure it on the new standard switch with its own two dedicated new network adapters. So that's what we decided. Although technically, we can configure the vMotion on the same switch as well. So we're going to go for best practices and new standard switch. Next. And it says, oh, it's a new switch, so why don't you add network card for that? So yes, we do, we will. And we're gonna give it two dedicated network adapters, right? So just keep the control key selected and select the second one and press OK, because this is exactly what we're gonna do in E6i3 as well. We are preparing E6i2 hypervisor and E6i3 hypervisor for vMotion or virtual machine migration. Right? Okay, next. Then it says, what do you want to configure here? So we're saying you can give any name. So we're going to give it vMotion. That's exactly what we're configuring. And we're not configuring VLAN on that. It's going to be IPv4, right? And there is MTU. We don't need to change that. And TCP/IP. So it also has this whole TCP/IP protocol can be dedicated for vMotion because vMotion is a very sensitive and critical feature, right? So we can select like this as well. And later you want to add another feature like fault tolerance, or you want to add another feature like management or provisioning or replication or vSAN. You can do that on the same. This means that the traffic of vMotion and it can be shared with any other advanced features as well. But then there is another option here, this one, where if you select vMotion, it will dedicate this adapter with two network adapters and this standard switch. It will dedicate this only for vMotion, and you cannot configure any other advanced features with the vMotion. If you remove that, then you can. It's just going to slow down the network overall. But you can actually say that, no, if it's vMotion, I don't want any other traffic to be configured in future. So we're going to do that. So both options are technically available. We're going to go for this and next. So VM kernel adapter requires its own new IP, separate new IP, right? So we can go for any unused IP in our network to be given to the VM kernel adapter, which is offering networking services to the advanced feature called vMotion, right? So whatever IP we haven't used, we can use that IP. I need to know what IP we haven't used. So I'm going to go to DNS. How do I go to DNS? I'm going to go to Server Manager, then go to Tools on the top right, and then DNS, open the DNS, and then check that what IPs are already being used and what are available. So if I go to Server Manager, then on the top right, I go to Tools, then I go to DNS, Power Lookup Zone, and then the domain zone. So we have used 10, 1, 2, 3, 4. So 5 till 9 are available, and then 11 till 49 are available, and then 101 till 254 are available, right? Okay, so 5 till 9 available. So we can give 46i2 the IP5 and E6i3 the IP6, whatever we haven't used yet, right? And the third octet here is 16. Okay, got it. So I'm just going to close the DNS 5 and 6, right? And minimize the server manager. So I'm going to select here and go for 192.168.16 or your third octet dot 5. So this we haven't used in this network till now. 255.255.255.0. Yep, that's all. We don't need to override gateway. Next. That's it. So it's configured now. Finito, right? We're going to configure the same for E6i3 as well. Finish here. I'm going to go to E6i3 now. I'm already on configure, already under networking. I'm on VM kernel adapters. So I'm going to just add networking or add VM kernel adapter for E6i3 to prepare it for vMotion as well. I'm just going to click that. Yes, the top option is there to prepare the hypervisor 3 for vMotion. So it is already selected. Next, as vendor best practice, we're going to go for a new standard switch. Next, we're going to add the next two available network cards, either shift or control, whichever key you keep pressed. So 2 network cards are also selected. Next, yes, pretty much the same thing. vMotion is the name of this VM kernel adapter. VLAN ID 0, IP setting v4, MTU no change, TCP IP stack. We have both options. Either we can let other advanced options be selected here, or we're going to dedicate this standard switch and its 2 network cards to only vMotion traffic. Then we can use that too. Next. Yep, next available IP is 6 for me. So I select that, change the IP 5 to 6. Click here and 255.555.0. So pretty much the same thing. And click next and finito. We're pretty much kind of ready, but let's just check that. What are the rest of the prerequisites? Make sure we should 0 have 2 port groups, 1 for management, blah, blah, blah. No, the port groups are there. At least 1 port group should be there, right? Make sure our VM has an operating system. Well, the good thing would be you can try it later as well, that put an operating system inside and then vMotion. But right now we will do the vMotion with empty machines. With or without an operating system, the vMotion works the same way, right? Let's create a new data store. We have enough data stores already. Let's move our VM with OS installed. Yeah, so we're gonna move our VM now. That's the thing. Okay, so what's the plan here? Plan is that we're gonna select one virtual machine out of the three. We're gonna move it from ESXi2 to 3 with the cold migration, which is the machine will be off. We're gonna migrate it from ESXi2 to ESXi3, right? To test how cold migration works. Then we're gonna do a suspended migration. We're gonna power on the machine. We're gonna suspend it. Then we're gonna migrate back the same machine from ESXi3 to ESXi2 to know how suspended migration works. Then we're gonna power on the machine, and that's the main one. And then we're gonna migrate this back from ESXi2 to ESXi3, right? Then we're gonna go for, we're not gonna go separate storage migration only. We're gonna do the storage migration with this option. Like we're gonna migrate the machine as well as the storage from one data store to another, and the machine one host to another. Then we're gonna do that 2-in-1 migration. Its virtual disk will move from one data store to another, and the virtual machine itself will move like before from one host to another, right? So we're going to try all these 4 migrations types. So let's go for the first one, which is cold migration, which is that the machine is off. Can you migrate from one host to another? So we go here, and I'm selecting VM01 for no particular reason. We can select any other machine as well. It is off, so I need to migrate it from ESXi2 to ESXi3. Right click is VM01, right click, and go for migrate. And then the wizard starts. Yes, change compute resource only, like change from one hypervisor to another. Storage only will only move virtual disk from one data store to another. Change both compute resource and storage is that last option in the slide, that change the virtual machine from one host to another, and its virtual disk from one data store to another data store. So we're going to do that at the last, but first let's just do the cold migration. So first option, next. Here, I know my machine is on ESXi2, so I need to select ESXi3, which is I need to drop down this here. Yep, it shows me ESXi3 as well. I need to select it, ESXi3, and the compatibility must say green. Select 3. It should be green, which means okay to go ahead with the migration. Next. Yeah, it says that, hey, you're going to migrate across the data center. Remember that ESXi2 is in TORDC, Toronto Data Center, and ESXi3 is in NYDC, right? So it's saying, hey, check the network if it is different or same. We know that it's the same, so we can ignore this warning and click next. And that's it, ready to complete. So we're expecting that this machine will migrate from ESXi2 to ESXi3 here. It will be in ESXi3. Finish. So keep an eye on that. VM1 was there in 2, now it's on 3. But this is cold migration. Now, which one is next? Suspended migration. Let's do that. We're going to power on the machine, then we're going to suspend it and migrate it back from ESXi3 to ESXi2. So right click the machine, power on. It's powering on. Once it is powered on, then we're going to suspend it. So right click, power, there's the suspend option. Yes. So suspend icon is an equal sign. Right now it's green. I hope it changes. Otherwise, I'll press refresh. Is it the same thing that it's not gonna change the icon? So I'm just gonna refresh the browser, this one. Oh, well, I will have to assume it's suspended because it's not. Oh yeah, it is suspended, not assume. It shows the green, the yellow equal signs, the vertical equal sign, which means it is suspended now. Now I'm gonna migrate it back from E6i3 hypervisor to E6i2. Right click, migrate, same steps. Change compute resource only, same. Next, my target now is, it is in 3, my target is 2. So 2 is showing here. I'm going to select that, and compatibility window should say good, green, succeeded. Next, yeah, network is same. We can ignore this warning. Next, yep, that's it. Finish. Let's see. Oh, it's back to 2 with suspended state. So the migration is good. Now we're going to go for the main migration, which is vSphere vMotion, where the machine is powered on, and we're going to migrate it across the hosts again. So we're going to power it on this time and leave it at that. Okay, the yellow icon changed to green, which means it's powered on now. So I'm just going to right click and do the same steps again, migrate. This time my destination is E6i3 hypervisor. So I'm just going to scroll down and select that. And it should say compatibility is good. Next, ignore the warning. Yeah, networks are same. Now there's an extra window called, do you want to schedule it at certain other time, and do you want high priority CPU to be given to this? Yes, I want CPU to be giving high priority to this task. So I'll keep it like that, and I don't want to schedule it some other time. I want to schedule it now. So that option will be still selected, and next, and finish. So VM01, it's still powered on, and it has moved to E6i3 from E6i2. Yay. Okay, then the migration vMotion finale, and that is cross-host vSphere vMotion, where what we're gonna do is we're gonna check where is the virtual disk of this virtual machine, which data store the virtual disk of this virtual machine is on. So this is the virtual machine. I'm going to check the data store. So select the virtual machine and click the data store to know which data store the virtual disk of this virtual machine is on. If I click that, it's on data store 3. So I can select the destination data store to be 2 or 1, whichever, right? And I know that this virtual machine is on E6i3. It needs to go to E6i2 now. So the virtual machine will travel from E6i3 to E6i2, while its virtual disk will travel from data store 3 to whichever we select, maybe 2, data store 2 as well. We can select data store 1 as well, whichever. So now this will be 2-in-1 migration, right? But if our virtual machine is empty, so that's why it's gonna happen fast. If it had an operating system, then it would be very slow, and you will have to wait, because a whole 10 GB, 12 GB, 15 GB disk will move from one data store to another, right? Right now it's empty, so it's going to be fast. So right click, procedure is same. Migrate. Now I'm going to go for the third option, which changes the data store as well as the host or hypervisor. Third option, next. So it says compute resource. I know that it's on E6i3, so we're going to E6i2. So I'll select that. But now it says which data store your virtual disk will travel. I know that currently it's on data store 3. I'll put it 1 for no particular reason. I can select 2 as well, but I'll go for data store, LAN-based data store 1, right? That's it. Next. Yeah, network is same, so we can ignore. Next. Yeah, give high CPU priority to this. Next. That's it. Finish. So now data store should change and host should change here. For virtual machine and its virtual disk, data store should change if everything goes well. Yeah, host changed and data store changed as well. It is 1 now. Before it was L3, now it's L1. Okay, so both migrations worked fine. Yeah, Nima.
I tried to migrate, but my one says that EXI02 is not responding.
Oh, then restart it and try to ping it. It's just communication.
Okay.
So guys, take a screenshot of this. If you have done it on your lab, take a screenshot of this. That vMotion works. Otherwise, take a screenshot of my screen. Take a screenshot of my screen. Take a screenshot of my screen. And the label one, screenshot one name is vMotion works. So I'm gonna take screenshot and put it here, and the screenshot one name is vMotion works. Right?